I think you are wondering with which profile type we ended up with, and we ended up with a profile type looking like, as you can see, the picture number 2, the ski mat, but we wanted to be sure that these stripes, as you can see on the side, are not going to detach, because before it was not happening often, but it still sometimes detached. So we have, as Arthur said, called our sponsors Handwerkskammer, and we're putting these we're creating this profile on CAD program SolidWorks, and then we laser cutted it there with a water laser cutter. Sadly, we don't have any photo, as I can see on our presentation, of this profile, but we definitely have a graphic of it in our design report. The main construction of the wheel was crafted during the pandemic. As you can see, the framework or the disc of our wheel is made out of lasered aluminium, and the center hub was also laser cutted. There you can see the 26 plastic pipe segments, and in between these segments there are the black, more robust segments, also 26 of them. Alright, now we come to point 3.3, our front axle design. Since years we finally made a difference or a change in our front axle design. Our original plan was to redesign everything, but depending on the time constraints, we decided to change our design a little bit, or our idea, and our current design is to integrate fiberglass springs for the enhanced suspension and comfort. That means that these front axle wings are going to be made out of fiberglass, and that's why it won't. The fiberglass is going to be a bit thicker, so that we don't bend over if we are jumping or driving above obstacles. It's going to be very thick, so that we don't bend down, but have still a good suspension and comfort while driving. These fiberglass springs provide stability and flexibility and have a very long service life. We also have inserted one of these fiberglass springs in the back seat of our rovers since about 10 years. The original one never broke. It's still in our rover, that's why we are very trusting on this. Fiberglass springs. Our sponsor S-Ply is located in Germany and is the main leader in fiberglass in the whole world. And they are supporting our project and looking forward for more work together with us.
Let's move on to a sadly long forgotten idea of us, the steering brake. This idea originated in the Team Germany, which is now called Rovernauts, in 2011. And we used it successfully at the moon buggy race in the years of 2011 and 2012. Our aim was to integrate or install it as a part of our front axle, which worked in 2011. And it was an upgrade to our existing brake system, but it worked in a very different way than the usual brakes that are meant for wheels. The steering brake was meant to, as the name is kind of telling, to fix or to brake the steering of the moon buggy, so it does not shake, for example, while driving over an obstacle, driving up on a hill or driving down on a hill. So the brake of this part is in the front axle, and when you pull the lever for the steering brake, you cannot change or move the steering, which locks it in, and it worked almost flawlessly in 2011. And now we would like to reintegrate this idea into our moon buggy for 2024.
Thank you, Arthur. On this point, I want to just implement very shortly that we have already designed the steering brake in 2011 and 12, but since then we haven't used it, and also the students that integrated it in our rover are not with us now. They grew bigger and they have their own jobs now, so we have to figure it out again and explore it again to build it in our rover again. Oh my god. Okay. Arthur?
The differential gear is something we are very proud of because this is a core piece, or the core piece of our rover, located in the front axle as well. You probably know what differential gear is for. So it's for the translation of the different spinning speed of the wheels during a turn. It was designed the designing progress started in 2008. But yes, please excuse me. The differential gear allows us to do the sharp turns, or for example the previously mentioned U-turn at 40 kilometers per hour. It consists of 3 cone gears, and they can resist a force of 300 Newton meters.
Yes. Thank you. On this point, we want.
So I wanted to add that our students years ago did it. So yes.
Yes. On this point, I want to implement that we have these differential gears also in little models, as you can see on this one. This is not a differential gear that you can set into the rover, because this is 3D printed for our students or for us to disassemble, to take a look at the differential gear, to understand how it is working. And as you can see here, this is also 3D printed. That's our Ritzel of the last year. We also wanted to participate last year on the HERC on the robot challenge. And that's why we also invented or tried to build the belt system on our rover. You know, normally we use chains, and this was our new design, but now we try to attend again, and hopefully it's going to work. So, as you can see, that's our model to take a look at and to learn, and that's the real differential gear that's also set in our rovers. It is made out of more stable, as you can see, materials, and also these black gearboxes are made out of plastic supported with fiberglass segments. Alright. On this page you can see some more drawings of our differential gear, and also an explosion drawing.
So now I want to talk about our seat. So since our first participation, we have built our own seats. Unfortunately, due to the construction and material, we noticed that there are not longer assistants. So we want to revolutionize it, and our goal is to have the seats more lighter, more comfortable, and easier to handle. And we are using the ultra light recumbent bicycle seats